The three terms LC50 is used for the concentration. That means liquid toxicants. Liquid toxicants. LD50 is for the solid. If you provide the solid for the determination of the 50 dose for the mortality. And third one is the infective dose 50. Infective dose 50. And now we are discussing on this part in my last class also. The idea of probit analysis was originally published in the Science. Science is the name of journal, most prestigious journal. Science and Nature, both are the most prestigious journal of the world. By C.I. Greece in 1934. Now, after that, David Finney took the idea and published a book, Probit Analysis, in 1957. Of course, the methods, a number of methods, like algebraic methods, binomial methods, methods by the integration, calculus. There are a number of methods which were used between the 1934 and 1955, 55 and 56. But the David Finney simplified the method for the calculation of the probit analysis and published a book, that is Probit Analysis, in 1957. Of course, he also presented a table for the determination of the probit. The probit analysis is used to analyze various kinds of dosage response. And like in the toxicology, pharmacology, environmental biology, microbiology, parasitology, etiology, that is used a wide range. If you want to go move in the field of any of these, then it is necessary to know a proper understanding of the determination of the LC50 or LD50 or identity. Now, the probit analysis is fundamentally based on the binomial approach. Probit analysis is fundamentally based on the binomial approach. Of course, if you want to determine the death rate, then another part is the survival rate of the survival. That means the two parts, the outcome has the two parts. If you treated any components, then the outcome has the two parts. And when any outcome has the two parts, it is commonly referred to the binomial distribution or binomial events. Binomial distribution or binomial events. As the event is the binomial here also, that means it represents graphically a sigmoid curve. If you simply draw the structure, then it represents a sigmoid curve. And in last class I also told you that on the x-axis we commonly consider the independent variables, and on the y-axis we commonly represent the dependent. And if we represent the graph with respect to the dose and mortality rate in the binomial form, then it represents a sigmoid. And it is fundamentally we are at the first convert the sigmoid curve into the linear by the use of the regression. By the use of the regression. And here, this one is mentioned that in the probit analysis, the response is always binomial, and the relationship between the response and the various concentration is always sigmoid. The analysis acts as a transformation from sigmoid to linear and then runs a regression on the regression. Clear? And here, in my last class, another component is mentioned here. The same line is represented here, y barabar a plus bx plus e. Here, a represents the intercept. If we move in the y direction, that this part is represented as a. Angle represented by b. And third component is e. Third component is represented there, that is the E. And E, it is commonly referred as error, but it is not error. It is not error, but it is referred in the form of E, that is the error. but it is not there. It is actually the residual value. It is actually the residual value. The residual value represented the deviation of the y hat to y mean value. Y hat to y mean value, which we will discuss later. Give you in my last class. For the calculation, it is a basic theory. For the calculation, treatment concentration is converted into log with base value 10. When you proceed for the analysis of the regression, for the determination of the linearity, then in the first step, the treatment concentration is converted into log with base value of 10. That is the log 10. And mortality percentage is adjusted by probability conversion table presented by Philip. Now, it is the table of Philip. And suppose that 10%. 10% means the table value is 3.7. If we 45%, then 40 and 5. That one is the 45. This value 4.87 is the probability value. The table is presented by Finney in 1957. 1957. And after the presentation of the probability table by the Finney, the method for the probability analysis is simple. And the second part, before we are proceeding for the calculation by the regression or test of the linearity, then for the calculation, treatment concentration is converted into a log with the base value 10 and mortality percentage is adjusted by probability conversion table presented by Finney. Clear? The ordinate represents dependent variable. When we are moving towards for the graphical representation, then the ordinate represents, ordinate means y-axis represents dependent variable and abscissa x represents dependent variable. Clear? We have the two ways to calculate the at first B. At first we calculate the B, and we have the two ways. One directly by the data we obtained by the experimental conditions, because it is the experimental analysis. अगर एक्सपेरिमेंटल नहीं है तो इसकी कोई आवश्यकता नहीं है. जब आप एक्सपेरिमेंट करेंगे, आपको कई मॉर्टेलिटी जानना है, रेट ऑफ मॉर्टेलिटी जानना है आपको, तभी आप करेंगे. अदरवाइज आप उसको नहीं करेंगे. नहीं करेंगे तब. And if you want to determine the mortality, then at the first you calculate the data, rate of different concentration, rate of the different in the different concentration, what is the rate of the mortality of the animal or fish or whatsoever जो भी आपको करना है. If you want to analyze the efficacy of the antibiotic, then you treated the bacterial colony. They are both different, suppose that is. And then we have the two ways. One, we calculate directly. Regression coefficient we calculate directly by the data, by some statistical processing, or through the correlation. But here, I am saying that two factors. It is not the cause and effect. कभी भी इसको आप cause and effect treatment से confuse नहीं करना. ये it is probability जो होगा, it is not the cause and effect. ये cause and effect को नहीं बदलाता, confuse नहीं करना. इसीलिए देखिएगा in maximum books or in maximum papers, it is calculated directly without undergoing to the calculation of the regression. Correlation. Without obtaining the correlation value, majority workers calculated directly the regression coefficient. But I am mentioning here both the methods for the calculation of the regression coefficient. I am mentioning here the both methods, that is regression coefficient B. It is the direct summation xy, small x and small y. You must understand the difference between the small x and capital capital X or a small y and capital X. I told repeatedly in my different classes that a small x means mean deviation. Total of the mean deviation of the x values. A small y means total of the mean deviation of y values. Okay? So that is the summation of the x, y. That means the multiplication value of the respective deviation of the x from the mean and respective deviation from the y from the mean. And now the summation of the x square. That means x square here represented the x minus x bar. X square, a small x represents the capital X minus mean. Capital X minus mean, value of the capital X, the value. That is the basic difference. इसको कभी confuse करेगा तो फिर उल्टा पुल्टा हो जाएगा तुरंत. A small x statistically, a small x is the different and capital X is the different. A small y is the different and capital Y is the different. दोनों different है. So here summation x y divided by summation x square. A small x, I have repeatedly write a summation of the small x y divided by summation of the small x square. That is the summation of the deviations from the x mean, then multiplied by the deviation of the y mean. That means the deviation from the x mean and deviation from the y mean multiplication value of the each is the summated upon, and that is divided by the summation of the deviations from the x mean square. Clear? In this way, we calculate the regression coefficient B. In the second way, if we want to determine the by way of the correlation, I am just mentioning here that in sometimes you want to analyze the relationship between the two factors in your thesis, and then you again want to determine the lethality. In that condition, it is not necessary to move further for the calculation. You are free to calculate directly from the correlation coefficient. That is the correlation coefficient. And if we want to move or calculate the regression coefficient by way of the calculation of the correlation, then the formula is R multiplied by ratio value या ये क्रॉस प्रोडक्ट ratio value R क्रॉस प्रोडक्ट value sorry ratio value of the standard deviation of y divided by the standard deviation of x. ठीक है? R represents the summation of x y divided by root under summation of x multiplied by summation of x square multiplied by summation of y. This one is the correlation. It is the correlation. This value represents the correlation. Okay? And then you put the value of the correlation here, a standard deviation of y divided by x, a standard deviation of x. That means that you easily calculate the regression coefficient. Here, we observe here clearly that denominator in this calculation is always positive. Here, the denominator is always positive. Denominator जो होगा वो हमेशा positive. Whereas nominator should be ऐसा करेंगे. हाँ, nominator should be. उसको ठीक कर दीजिए. Nominator should be. Whereas nominator may be positive, negative or zero. Nominator positive भी हो सकता है, negative भी हो सकता है और zero भी हो सकता है. Hence, the value of B means regression coefficient, theoretically ranges from minus infinite to plus. It is minus infinite से plus infinite हो सकता है. So this one, by this way we calculate the value of B. In next, we want to develop the value of A, that is the intercept, and A is calculated by mean of the y बराबर A plus B mean of the x. Then we calculate the B from the here, and when we put the value of B, then we get the value of A by way of the, this one is reorganized, A बराबर mean of the y minus B into mean of the clear. In this way we calculate the value of A and
B.
value of B. Okay, you suppose any value whatsoever, कुछ arithmetic का value आएगा, कुछ number आएगा. You write here y बराबर जो भी value आएगा, मान लीजिए n value आया इसका plus m value आया इसका x. It is the numerical value. n is the numerical value, m is the numerical value. And now a equation is developed here by the putting of the value of the a and b. When you will put the value of the a and b, we obtain the a equation here. That equation is referred as the regression equation. Regression equation. The equation is referred as regression equation. And now we are free to put the value of the whatsoever we want. We put the value of the x, then we get the value of the y. Whatsoever 1, 2, 3, 4, 5, 6, 7, 8, whatsoever. We give the value of x and we get the value of y with respect to the value with what we put here. Okay, and now this derived equation y is referred as y hat. It is represented as y hat. Reads as y hat. अब इसको क्या बोलेंगे y hat. Clear?
Yes.
And now the difference between the y hat and actual value of the y is total. If you sum the square value of the y hat and y, it is the minimum. It is the characteristic of the regression. It is the characteristics of the regression line. And if any chance of the variation is observed in this y hat and y, that is referred as the residual value. That is represented by E. Clear? We want to LD 50, yeah, LC 50, yeah, ID 50. That means the high probability value. Probit value, sorry. High probit value. Then you put the high at the place of the y hat. And now you put the value of n. What we find in the calculation value? Then we find the m and xi. This calculated value represents the LD 50 or LC 50 or जो भी आप इसको regression equation. That is the regression equation. We should find the value of x at probit value 5 of 1. Okay? As the calculation is based on the derived value of log at 10 base, because we calculate here from up to the LD50 in the form of log. In the form of log. वहाँ पे जो भी हम x प्राप्त कर रहे हैं वो किसके फॉर्म में प्राप्त कर रहे हैं? लॉग के फॉर्म. और मेरा कंसंट्रेशन क्या है? लॉग के फॉर्म में नहीं है, जो एक्चुअल हम लिए हैं. तो लॉग के फॉर्म में भी you are free to represent the graph in the form of log, in the form of probit. probit के फॉर्म में आप ग्राफ रिप्रेजेंट कर सकते हो, तो कोई आपत्ति नहीं. ठीक है? और जहाँ पे फायदा अभी हम बता रहे हैं. But we want to get the actual value. What is the actual value? हमको चाहिए क्या? What is actual value? Because it is the primary stage of your research. ये primary stage होता है. Because you want to different graded treatment under the LD50. क्योंकि आप जो एक्सपेरिमेंट करने जा रहे हैं, आप जो जर्म्स को इन्फेक्टिव रेट को आप पता करने जा रहे हैं, या जो भी पता करने जा रहे हैं, एलसी का पता करने जा रहे हैं, तो आप उसको मारने के लिए नहीं जा रहे हैं, आप उसके एक्सपेरिमेंट करने जा रहे हैं, आप उसके बारे में पता करने कर जा रहे हैं. तो आपको मारना तो लक्ष्य नहीं, इसीलिए आप उसको देना क्या है? आपका जो डोज होगा ऑलवेज क्या होगा? लेस देन द LD50, लेस देन द LC50 और लेस देन द ID50. हाँ, अगर ट्रीटमेंट इफेक्ट देखना है, मारिए देना है, लाइक द पेस्टिसाइड, हमको इफिकेसी ऑफ द पेस्टिसाइड देना था तो मारेंगे, लेकिन मारना तो मेरा काम नहीं है. हम लोग भाई बचाने वाले आदमी हैं, मारने वाले आदमी नहीं। तो हम क्या करेंगे, उसको जो ट्रीटमेंट देंगे वो बिलो LC50 देंगे या बिलो LD50 देंगे, क्योंकि उसके एक्चुअल नेचर को हमको देखना है, एक्चुअल नेचर को प्राप्त करना है। एंड इन दैट कंडीशन, बिकॉज इट इज इन द फॉर्म ऑफ द log, we convert the value into the anti-log to obtain the actual value of the toxicant. Actual value of the toxicant. That is right. As the calculation is based on derived value of the log at 10 base, the anti-log of calculated value of x at 5 value of the probit is obtained to determine the LD50 or
LC50.
Clear? And for example, we want to represent a graph here, a typical graph. It is a typical graph. जब भी आप ड्रॉ करेंगे तो इसी ढंग से आएगा। And here you see here, that is the actual value. Blue point is the actual value. It is the actual value. And after the regression equation, it is the regression line. Then we pointed this one. Then we draw a graph, and from the probit value 5, it is the probit value 5. You draw a line in parallel to the x-axis to touch the regression line, and from the regression line, you draw a parallel line to the y to the x-axis. And here the value 4.25, that is represents the log value of the LC50. It is the graph का representation. It is the LC50 और LD50 जो भी होगा, ये क्या है, लिक्विड है, हाँ, लिक्विड, ठीक। It is the LC50, value of the LC50. And when you want to, or anyone want to determine the actual value, he or she converts 4.25 log value into the anti-log. That is the LC50. Clear? In my last class, I told you that only the regression line is not sufficient. When you move in the research, then two other components are also necessary. One is to test of hypothesis for the regression constants. Regression constants कौन से हैं? A and B. A and B are the regression constants. Second, the 95% CI, 95% confidence interval of probit value, that is y, with respect to x. Then you see here, like here, if we here observe, this is the actual value, this is the actual value, this is the actual value, this is the calculative 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 value. This one is the actual value, this one is the actual value, this one is the actual value, this one is the actual value. That means the actual value and calculative value has some differences. This one represents the y hat value. This is the actual y. Clear? This is the y hat. अब आपको समझ में आने लगेगा जब हम जो बोलेंगे. This is the y hat. This is the actual y. And there is some difference. That means it is necessary to represent the 95% confidence interval for the each values. And the two further analysis is necessary for the research. अगर रिसर्च नहीं कर रहे तो टाइम में भी आप छोड़ दीजिए, चले जाइए एक बार पढ़ के केमिस्ट्री. But when you move in for the research and want to incorporate all these facts in the thesis, then it is necessary to move to a stage further. One, to test the significance level of your B value. Significance of the B value. Because A is not commonly changed, but B is changed. And when the nature of the B is changed, the line moves either here or here, either upward or down. जैसे ही आप B को चेंज करिएगा तो ये लाइन ऊपर नीचे भागने लगेगा तुरंत. और जैसे ये ऊपर नीचे भागेगा तो अभी हमने अपने आपको बोला कि इसका निग्रेशन का नेचर चेंज कर देगा, तुरंत चेंज कर देगा। दैन हियर, तो यहां पे आपको दो चीज चाहिए कि आपका जो ट्रीटमेंट है वो सिग्निफिकेंट है कि नहीं। जो ट्रीटमेंट आप कर रहे हैं वो सिग्निफिकेंट है, आपको ऐसा ही अंदाज से मिल गया, चांस से मिल गया। और दूसरा कि इसका 95% कॉन्फिडेंस इंटरवल ए और बी का, या बी का और एक्स एक्स वाई वैल्यू का, बी का और एक्स वाई वैल्यू का, ये पॉइंट वाई का वैल्यू आ रहा है, ये वाई वैल्यू आ रहा है विद रेस्पेक्ट टू एक्स, ये 95%, मतलब इसके रेस्पेक्ट में ऐसे, फिर इसके रेस्पेक्ट में ऐसे, फिर इसके रेस्पेक्ट में ऐसे, वो क्या दैट इज रिप्रेजेंटेड बाय द 95% कॉन्फिडेंस इंटरवल। क्लियर? टेस्ट ऑफ सिग्निफिकेंस, टेस्ट ऑफ सिग्निफिकेंस, there are the two methods are described in the different books or literatures. If you go through the different books and literatures, there are the two methods. One by the ANOVA, that is the F test. ANOVA F test. Another is by the T test. The calculation by the way of the ANOVA is a bit complex than the T test. ठीक है? Second point, that for the calculation, for the test or T test, it is necessary to calculate the क्या extended error। लास्ट कॉलम में हम आपको पढ़ाए हुए हैं कि डिफरेंस ऑफ द पॉपुलेशन मीन माइनस मीन एट द नल हाइपोथेसिस, पॉपुलेशन मीन एट द नल हाइपोथेसिस डिवाइडेड बाय एक्सटेंडेड एरर ऑफ मीन्स। ये सब याद रखा करिए आप लोग क्लास में। when we want to check the hypothesis, to test the significance through the T test, it is also necessary to calculate the extended error of means. And when we calculate the extended error of means, then we easily calculate the 95% confidence. Okay? So here I am going to use T test, not error. यहाँ हम आपको जो आगे बदलाने जा रहे हैं वो T टेस्ट बदला है, हम ANOVA के द्वारा नहीं बदला। लेकिन इसका एक दूसरा भी रास्ता है सिग्निफिकेंस टेस्ट करने का, वो है ANOVA, दैट इज द F टेस्ट। F टेस्ट, ठीक है? ANOVA based on F test. Here, when we moving for the hypothesis testing, we assume at least 5. 5 are our assumptions. ये क्या है? Assumptions. First, assume that for any value of x in population, a normally distributed y value exists. हम पहले भी बोले, हम विषय में पढ़ा रहे हैं कि T टेस्ट वही यूज होगा जहाँ पर नॉर्मल डिस्ट्रीब्यूशन। अगर इरेगुलर डिस्ट्रीब्यूशन है या फ्लक्चुएटिंग डिस्ट्रीब्यूशन है तो वहाँ पे T टेस्ट यूज नहीं होगा। ठीक है? तो पहला यहाँ पे assumption है कि x के रेस्पेक्ट में y वैल्यू जो एग्जिस्ट कर रहा है वो क्या होगा? नॉर्मली। दूसरा, assume homogeneity of variances. वेरिएंस आप समझते हैं, सब लोग समझते हैं। उसी पे स्टैंडर्ड एरर बनता है, उसी पे स्टैंडर्ड डेविएशन बनता है, सब किस पे बनता है? वेरिएंस पे ही डिपेंड करता है। तो दूसरा assumption होगा कि जो वेरिएंस है वो होमोजेनियस है, यानी ये सब जो हम एज्यूम कर लेंगे तो इसको ये इसके लिनियरिटी का हम क्वेश्चन नहीं कर सकते, तब इसके लिनियरिटी पे क्वेश्चन नहीं। थर्ड, एज्यूम दैट द एक्चुअल रिलेशनशिप इज लीनियर। ये दोनों जैसे ही होगा तो तीसरा जो होगा वो एक्चुअल रिलेशनशिप जो होगा वो लीनियर होगा, इसमें कहीं प्रॉब्लम नहीं। एज्यूम दैट द वैल्यू ऑफ x आर टू बी इंडिपेंडेंट टू ईच अदर, दैट मींस व्हेन वी टेक द वैल्यू ऑफ द y of 1, it does not affect to the y value of the other one, because here we use the different rules. किसी को कोई मतलब नहीं। Assume that the measurement of x are obtained without error. It is hypothetical. हम साफ बोल रहे हैं। It is hypothetical. We assume, but actually it is not possible. Actually it is not possible in any population. But we assume it. In actual condition, the fifth one is not possible. But up to a range, जहां तक हम स्टडी कर रहे हैं वहां तक हम लिनियरिटी प्राप्त करते हैं। और इसीलिए जहां तक हम काम कर रहे हैं, when we draw the line और रिप्रेजेंट ग्राफिकली, तो उससे बाहर का वैल्यू को नहीं लेना चाहिए। उतना ही वैल्यू में लेकर लाइन को आप बढ़ा घटा दीजिए, बट when you going to calculate the value for the y hat with respect to the y hat, x with respect to the y hat, you always want or vice versa कोशिश करता है कैलकुलेशन करनी है। तो आप जो रेंज में आपको फाइंडिंग है उससे बाहर, ठीक है। कंसंट्रेशन कंसंट्रेशन 1 2 3 4 5 जो भी लेना है 6 7 8 9 10 1 2। Now the concentration is converted in the form of log 10. It is converted into the form of log 10. It is considered as the x because it is on the x-axis. Now you take the number of mortality. Number of, and then it is the percentage. Okay? Then you percentage is converted into the probability table. Okay? This probability is y. Probability value is the y, not probability. Probability value is the y. Then x minus x bar, that is a small x. Clear? Y minus y bar, that is a small y. Then x and y. These are the essential components. We must calculate in the tabular form before moving forward for the calculation. And when we calculate this, you get all the calculations easily by putting the value in the different formula. Okay? Now, after the calculation and getting of the graph, that is the regression graph, after the calculation, we getting the regression graph or regression equation or regression line.